All right, so let me throw up the live stream here on Discord. We're transitioning into some more of my favorite stuff, which is kind of exciting. I don't know, climate and ecosystem dynamics. It's fun, but it's definitely not the thing in science that I'm passionate about. I really love chemistry. Some people find chemistry really hard, and it is totally understandable if you do not like chemistry at all. But for me, it's definitely my favorite realm of science. Biology's fun too, but chemistry, having the ability to blow things up and also literally explain everything about the world, to me, that's just the most exciting part. Let's see here. Oh no, that's gonna do something silly if I do that. If I click through like this, can you guys see that? If I'm clicking down and up like this on the slides, can you guys see the slides changing? Someone tell me if that's working. Is this working? Okay, lovely. Thank you so much, Aiden. Okay, so I'm gonna just do it like this then. We'll see how well this works. But basically, what we are going to start working on is we're going to start working on looking at the periodic table of elements. In and on your Science 10 Google Classroom, I posted a materials you may need section under classwork, so you can access it there. It is also on Discord. So in the materials you may need section of Discord, you will likely want to grab the Physical Science 20 data table package. That contains a periodic table. You can also use one just on Google. There are some excellent ones on Google. But I also posted in the Science 10 Google Classroom, I posted the Chem 30 one. That periodic table is my favorite one. And it also contains something called a table of ions. And we don't need that yet, but we will eventually get to a point where you do need that information. But kind of what this PowerPoint goes through here is it talks about patterns among the elements. And so one of the assignments that you'll get out of this little stream today is you will get either the periodic table activity or the periodic table top secret murder mystery assignment. You can do one of those two. So basically, in 1867, Dmitry Mendeleev he proposed organizing all of the elements into a table. And he wrote all the information that he knew about the elements and wrote it down on cards. So that assignment or that puzzle, if you choose to do that one, that's kind of what Mendeleev did. Is he looked at all of the different elements and said, "I know these 3 facts or these 4 facts about it. Let's see how I can kind of organize these things." And some of the information that he did was color, density, melting point, and reactivity. And he came up with something that looked like this. I know that picture is super grainy, but that was the kind of periodic table that he came up with. It was not a terrible starting point. A lot of the elements that are kind of related to each other, we ended up later discovering that in fact they are a lot more similar than even what Mendeleev had thought. And so we ended up getting this final periodic table. Henry Moseley, he was the dude that arranged it in this matter. This is the huge periodic table now that you see in my classroom, hanging up by the window there. All of these elements, this is the best known way of organizing the periodic table of elements. And basically, this was created after Mendeleev as chemists discovered new or different elements, or if they discovered new or different patterns. So some of the things, like even color, that wasn't necessarily the best way of organizing the elements. That was later found. Instead, what was found was the masses of the elements, but also the number of protons and electrons that they have. And so in the modern periodic table here, the elements are organized according to their atomic number. I'm going to just quickly, let me just quickly throw up, where is my periodic table? It's in this one. Can you guys see this carbon here? Is that showing up on the Discord? Oh, it's not, is it? That's kind of interesting. Okay, let me just copy this. And let's go here. Let's fill in a blank slide and let's do this. Right. So this is what all of the elements on the periodic table look like. Within each of those little boxes, there's a bunch of different pieces of information. There's an atomic number, there is the element symbol, the element name, and then also the atomic mass. And each of those communicates a different piece of information. The element symbol, that is just simply how we represent carbon when we're explaining a chemical reaction. I don't want to have to be able to write the word carbon 1,000 times when I'm explaining a reaction to somebody. I want to just be able to write a C and have them know exactly what I'm talking about. The atomic number is how all of the elements are organized. So number 1 is in the top right hand corner here, or top left hand corner here. Number 2 is over in the top right hand corner over here, and then it goes 3, 4, 5, 6, 7, 8, 9, and then so on and so forth as they go through. All of the rows are called periods. So when you're looking horizontally across at the periodic table, those are called periods. All of the columns, those are called groups or families. And most importantly, the groups kind of tell more information than the families do. The groups, what they do is each element that's in a certain series will either be a metal, a non-metal, it'll have a certain amount of reactivity, it'll have a certain amount of protons that or electrons that are available for other elements to take. That's kind of what the groups tell you. And so when we're looking at this piece of information here, you guys won't do much with the atomic mass. For us right now, that's not the main concern of these elements in grade 10. When you get to grade 11, however, the atomic mass is basically all you work with. You really don't care about the atomic number very frequently. There's only a few circumstances when you're looking at number of valence electrons. That's when you care about the atomic number. But the modern periodic table, it's divided into both metals and non-metals. And I'm just going to post another picture, periodic table, images. Where's a good picture? Yeah, this is why I don't like this one very much. Basically, there's a staircase that exists on the periodic table, and that staircase communicates which elements are metals and which elements are non-metals. So let me take a screen clipping of this here. We'll cut that out of there, and we'll put this in this presentation here so you can see. Okay, so the thick black line that exists there, what that does is that separates the metals from the non-metals. Separates the metals. So all of the things on this side, these are all of the metals. All of the stuff on the right side of the staircase, those are all of the things that are non-metals. And if you look at the actual elements that are on both sides of the staircase, you can kind of guess or see that, like, yeah, okay, that makes sense. On the left side of this staircase here, if we circle in on my personal favorite element, number 28 right there, that's nickel. That would make sense that that would be a metal. Most of the time when you guys have dealt with nickel, it's been a coin that has gone either in your purse or your wallet. Similarly, number 79 here, gold, what you guys are all hoping to eventually make with your careers or wear as a gold chain. That is also a metal. We frequently see that, and it's a solid object. When we look at the other stuff in the non-metals over here, we see things like oxygen. Most of you would be familiar with oxygen as a gas. And that means that it's not solid, and it also means that it's not a metal. Another one that some of you might be less familiar with would be helium. We're slowly running out of helium on this planet, which is really sad because when I used to go for my birthday parties at Rutgers, I used to get helium all the time and then run around and destroy everybody at the one where you throw the ball up the ramp and then you hit it in one of the holes. And my voice would be really more high pitched than when I was 13. So it was a really exciting adventure and time for me. But yeah, helium, again, you have experience with that coming as a gas, meaning it's not a metal. It's not something that would be typically solid. So that's how you separate the periodic table. The other things that, the other properties that exist on the periodic table, things that differentiate metals and nonmetals, things that are shiny, malleable. Most of the time, metals are conductors. Copper's an excellent conductor of electricity. I know you guys would have done some of that with Mr. U last semester, or last year, excuse me. And then also some of the properties that separate these things as well. There is some very clear differences between what exists as a metal and also exists as a non-metal. So some of the properties that we're going to learn about, some of the groups that we'll learn about. We'll talk briefly about the alkali metals at some point, the alkaline earth metals, the halogens, and the noble gases. The two that I want to talk about really quickly right now are the halogens and the noble gases. So I'm going to scroll over here. Everything that's in column 17, so this column right here, these are all of our halogens. Everything that's in column 17 is a halogen, and everything in column 18 is a noble gas. And so we'll talk about the noble gases first. Noble gases are interesting. When we start drawing Bohr diagrams, you'll see that they have something called a full valence shell. And basically what that means is when you're drawing the Bohr diagrams, they have the maximum amount of electrons in a ring. They can't fit any more electrons in that outer ring that they have. And so what that means is that these guys, these noble gases, are super unreactive. Super unreactive. You can put helium, neon, argon, krypton, xenon, and radon, maybe not, but these top four for sure, you can mix them with pretty much anything and they won't react. And that's part of the reason that helium has such a cool effect, but it's also part of the reason that helium gas we have such a difficult time producing, is because it's not reactive and it's also almost impossible to make as well, to create in a lab. So that's the noble gases. They're not very reactive. They're super stable. That would be another good point for me to write down. The halogens on the other side, these are some of the most reactive of all of the different elements. These are some of the most reactive. And these guys like to steal electrons. They like to steal electrons from other elements. And kind of similar to electricity, how things react is all through electrons. So if electrons are being either stolen or shared with some other element, that usually will indicate that a reaction is about to happen. There's some really cool stories of ships that are traveling across the ocean that have lithium fluoride in them. And those ships, if lithium fluoride ever comes into contact with water, it has the potential to be extremely explosive. And so there are stories of ships traveling across the ocean and a small little amount of lithium fluoride pours out into the ocean and the entire ship blows up. We did an experiment with the grade 12s last semester where I took pure metal sodium and I just poured water on it outside and we exploded a pumpkin doing that. So I'm hoping that if I get to teach you guys in grade 12, we'll also do that experiment where I'll explode some stuff just using pure metals. But that's basically all that we need to know about the periodic table. We're going to start using, so I'm going to pause this recording for the YouTube video. We're going to start using the atomic number on our next little set of PowerPoints here. And we're going to use that to figure out the number of protons, neutrons, and electrons, and then we'll have a brief conversation about those as well.